So we looked at the definite integral. Now the indefinite integral. Where do they get the names from? Well, the definite integral means we come up with a definite answer. There's no pronumerals left in it. We substitute numbers in, we have a definite answer. An indefinite integral is when we don't substitute in, we just leave it as a function. So we don't actually know what the final answer is because until we substitute numbers in. So basically it's exactly the same. The difference is I don't have my square brackets where I'm subbing numbers in because there are no numbers, but also the addition of a constant. Because remember, when you differentiate a constant, you get 0. So therefore, if I'm going back the other way, theoretically the 0 I could integrate to become a constant. So everything will have some constant in it. Unless we got more information, we don't know what the constant is, of course. This next one, which is sometimes called the useful theorem, because it's quite useful. But not true. I've actually seen it in textbooks called the useful theorem. Okay? You don't want to spend time expanding it out. So if it's a linear function, so it's got to be a linear function inside, we can still add 1 to the power over the power like normal, but we also have to multiply by the coefficient of x on the bottom. And then that saves time. I don't have to expand the whole thing out and then integrate. So it has to be a linear function for that idea to work. So if I've got 2 minus 5x to the power of 3, that is a linear function. I can take advantage of this idea, add 1 to the power over the power, but you'll notice on the bottom of the fraction there, I've also multiplied by negative 5, the coefficient of x. So we get negative 1/20th 2 minus 5x to the power of 4, but of course, plus a constant. I'm going to have to change this one to negative indices first. So it's the power of negative 2. Again, I can use my useful theorem. Really useful here because try and expand out 3x plus 1 to the power of negative 2. Go on, do it. I'll do it. Go on, there we go. See if you can do it. Yeah. All right. By the way, it is actually possible, but don't worry. We won't be looking at things like that. Add 1 to the power over the power, but also times 3 on the bottom because that's the coefficient of x. And of course, we don't leave it to the power of negative 1. That would be a mere mortal answer. Super mathematicians will turn that into minus 1 on 3, outside of 3x plus 1. Square root of 2x plus 1. Again, we'll have to put that in the index form. Go on, expand that one out. 2x plus 1 to the power of a half. Yeah. So we'll use our useful theorem. Add 1 to the power, 3 on 2. But we'll times that by 2/3. But also on the bottom of the fraction, multiply by 2, coefficient of x. And we get 1/3, 2x plus 1 to the power of 3 on 2. Well, at least the mere mortals do. Super mathematicians. We get 1/3, 2x plus 1 root 2x plus 1. Plus, of course, a constant. 11D. Wow. Imagine all those dimensions.